All right, everybody. This is going to be video number 3 for lesson 2. Apologize for the length of the first two. I didn't realize it was going to be taking this long, but hopefully this distance one goes a little bit quicker. So with distance, keep in mind that we talked about this in the last lesson, that distance always has to be a positive real number. So keep in mind that you can't run -3 miles, right? You have to, it's positive measure always. So when we're talking about distance, a positive real number, we can use absolute value to make sure that it's positive. So one way to use distance is to measure the length of segments. So in this case, if we wanted to say that we wanted to measure the distance of J to K, we could do 5 minus 12, which is -7, and then take the absolute value of it and get +7. Or in this example, we could take 12 minus 5 and still get the same result here, distance 7. One thing that I just wanted to use this slide for is to keep in mind when you're talking about the distance between 2 points, we just use the 2 points, I guess, as the naming system. We don't have like the little bar above it to represent a segment, because the length of a segment and the distance between 2 points are the same, but in this notation, just the letters JK, they're just talking about the distance between 2 points. Whereas if you have the bar above the 2 letters, you're talking about segment JK specifically. We can talk more about this as we progress here. If you have questions about it, let me know. Now, if we want to do the same thing for K to M, one way to quickly calculate the distance from K to M is to do 27 minus 12. Absolute value would get you 15. Or you could do 12 minus 27, which would be -15. And then we would just do the absolute value because, again, distance always has to be a positive real number, so it would be +15 here. And again, this is basically what I just talked about a little bit ago. The difference is in the notation of segment length. So if we were talking about the distance between 2 points, we would just use this 2 letters here. But if we wanted to say the length of a segment, like JK, we would have length of segment with the bar above it, segment JK equals 7. So there is a slight difference. I'm not going to be too picky, but I wanted to point that out just so you're aware of it. All right. Now, this is basically what you're going to have to do on the assignment, is calculate the distance between 2 points on a coordinate plane. So here, we have this graph here where A is located here and B is located here. Now, finding the distance between 2 coordinate planes actually makes use of the Pythagorean theorem. Excuse me. Pythagorean theorem, if you don't recall, is a squared plus b squared equals c squared. This can only be used if we're dealing with a right triangle. So, if we want to know the distance or the length of this line or the distance between A and B, it kind of works like this. A is really the horizontal distance that you would change, like the horizontal distance from A to B represents A. And the way that you calculate that is by using this absolute value. So we could say that A is at 3 for my X value. And keep in mind that horizontal distance is a change in X. So I'm using 3 here, and I'm subtracting 13 because that's the other X. And I can do the absolute value to make sure I have my distance as positive, which is 10. And then B is the vertical distance. So in this case, B represents the vertical change from basically A to B. So if I do the same thing, -4 minus 11 is a distance of 15 after you do the absolute value. And then one thing that you should notice here is that we actually have a right triangle. So the distance formula itself is derived from the Pythagorean theorem. Pythagorean theorem can only be used when you're dealing with right triangles. And in this case, when we're working in a coordinate plane and you're moving basically straight horizontal and then vertical, you're usually going to create a right triangle. So now, if we use the Pythagorean theorem, we can actually figure out what the length of A to B is by using 10 squared plus 15 squared equals C squared, and C represents the actual length of A to B. 10 squared is 100, 15 squared is 225. C squared is, again, C is the length of A to B. So if we calculate this out, we'll get 325 equals C squared. Then whenever you want to get rid of a square, you have to square root. So c itself is equal to the square root of 325, which is the same thing as 18.03. So that means that the distance from A to B is actually 18.03 units. I know that's a lot. That's why we're going to run through a couple examples here in just a second. So, distance formula. So, this formula right here should look pretty familiar because, as we said in the last slide, it is derived from the Pythagorean theorem. So, the problems that you're going to see on the assignment look pretty similar to this, where you're going to have 2 points, either plotted on a graph or just 2 points that are given to you, and you are to determine the distance between those 2 points. So in this case, we're trying to find the distance between A to B, which is just, again, you write the letters A, B. So the very first thing that I would recommend is that if you're dealing with points that are plotted on a coordinate plane, I would label those points, because labeling points is going to make your life a lot easier in this unit and, again, throughout the course. So if we have our points labeled, we can then kind of start to input them into this formula here. We just plug our x's into where they go in the formula and our y's into the formula as well. Again, I traditionally go alphabetically, so I would say that A is 0.1 and I would say B is 0.2. So that means that if I'm looking at my formula here, x2 would be this 2 right here. x1 would be this -4 here. y2 would be this -2. And y1 would be this 2. So you could go ahead and plug those in. That's what this would look like. We have 2 minus a -4. Keep in mind that a distance you're subtracting, which is different from midpoint, which is, people usually get those confused. They try to add and subtract with midpoint distance. Just keep in mind distance is subtraction. So we would do 2 minus a -4, which is actually 2 plus 4, which is a +6. And then you would square it. We have -2 minus 2, which is -4, which you would square. So a lot of this is just plug and chug. We can go ahead and simplify. 6 squared is 36. -4 squared is really -4 times -4, which is a +16. 36 plus 16 is 52. And then after we square root 52, we should be left with 7.21. So that means that the distance from A to B is 7.21 units. So that's what we would say for our answer. Let's move on. Another example, we're given these 2 points. This looks very familiar to one of the problems on the assignment. So again, always start with labeling the points. So, and then again, however you label them, you can name them however you want. I traditionally stick with the alphabetical kind of naming. So R is at -5, 3. T is at -2, -3. T becomes alphabetically after R. So if I were to calculate this out, I would use R as my 0.1, meaning that its x value of -5 would go right here, and its 3 would go right here. But again, it's pretty straightforward. All you're doing is plug in your x's into where they go, into the formula here for distance, and we'd have -2 minus a -5, plus, and then squared, plus -3 minus 3 here. We would then simplify. -2 minus a -5. So anytime that you're subtracting a negative, it's really addition. -2 plus 5 is 3. And then we have -3 minus 3 is -6. We would simplify this further. 3 squared is 9. -6 squared is 36. Simplify this further. 9 plus 36 is 45. Square root of 45 is 6.71. So in our answer, we would say that the distance from these 2 points, R to T, is 6.71 units. All right, one last example here. This would be pretty similar to what you have to do on the assignment, where they just give you actually the 2 points, so you don't have to worry about labeling them. Honestly, you just have to take your x's and plug them into the formula. So it would look a little bit like this. Oops. Where, again, alphabetically, F comes after E, so I would say that F is my 0.2. So the 11 would go where my x2 is, and then I would subtract a -7 squared plus 3 minus a -2. Simplify. 11 minus a negative 7 is 18. 3 minus a negative 2 is 5. Simplify further. 18 squared is 324. 5 squared is 25. Add them together, and we have the square root of 349, which comes out to 18.68. I believe this distance formula should be pretty straightforward, but if you have questions, let me know. Oops. Lesson 2 assignment is available on Schoology. Again, make sure that you're taking all the attempts necessary to try to make sure you get a 5 out of 5. Thank you.